Very often when you're working with data, you need to find the sum of x. Let's say you're looking to calculate the mean or the variance or the standard deviation. So we're going to need to get a list of all of our x values and add them up. But you have to be careful when you're working with frequency distribution tables. First of all, let me show you what we can't do. No matter how we work with this table over here where I've looked at M&M colors come in values that are non-numerical. I mean, they're either blue or they're orange or they're red, and so on. So we're not going to be able to do anything with this data. You can't take the average color out of these colors. So I'm going to get rid of that. But over here with my siblings data, where people were asked, how many siblings do you have? The answers like 6 and 5 and 4 siblings and so on, these are proper numerical values, and we can add them up. We can perform mathematical operations on these. But if you were to try and use this column to get the sum of x, look at what would happen. I would do 6 plus 5, that gives me 11, plus 4, 15, there's another 5, and finally I'm up to 21. This would be definitely the wrong answer. The reason that this is wrong is because this completely ignores the fact that there is 1 6 but no 5s, even though I added 5 in there. There's actually 4 4s, but I only added 4 once. I'm really not paying any attention whatsoever to the fact that I have varying frequencies, or I have different frequencies for these numbers. I just added up 1 6 plus 1 5 plus 1 4, so you can't do that. That's ignoring the fact that this table is trying to express in sort of a summarized form how many of each value you actually have, how many of each score you actually have. So one way to get around doing this, or one way to get around this problem, would be to go back to your raw data. When you add these up, when you go through one by one, value by value, and you add up all of these, it comes out to the sum of all of your scores being equal to 58. But doing it this way, especially by hand, is easily prone to errors. Takes a lot of time too. So I wouldn't necessarily recommend that, especially if you've already got a table here to help you summarize your values. All that we need to do is reintroduce the frequencies back into the value that's going to get added up to give me that sum of x. So that works like this. I have 1 6, so 1 times 6 tells me that I'm adding 6 into my total, whereas I have 0 5, so 0 times 5 gives me 0 that will be contributed towards the total. 4 times 4, that's 16, so my 4s in total will contribute 16 to the total. So I think you get the idea here. 3 times 3, so f times x, that's 9, 10 times 2, that's 20, 7 times 1, that's 7, and 3 times 0, that's 0. When I add these up, I will get the sum of f times x, but this is actually going to be the sum of x. It's the proper sum of x. It's as though we took all of this data and added the values one by one. So let's add this up and see what we get. 6 plus 16, that gives me 22, plus 9, that's 31, plus 20, that brings me up to 51, and another 7 brings me to 58. So this is equals to 58, showing me that my sum of x is 58. And that's what I got when I did these one by one. So this would be the method that you have to employ. So be careful. Do not just add up your x's. These are not actual scores. This is just the scale of values, of potential values that were showing up in your survey or in your sample. What you need to do is you need to make sure you've introduced or reintroduced the frequencies, because the whole point of the table was to separate frequencies from the scores. By using this column here, we're reintroducing them together and we can get a proper total.